Hello and welcome everyone. Myself Vinay, mathematics mentor. Hope you guys are doing amazing. In earlier classes, we have already gone through the important points related to a triangle, and those are centroid, incenter, circumcenter, and orthocenter. Hoping that you have already gone through the lecture. If not, please go through those videos because that points are very much important in terms of triangle. So now in today's classes, we are going to have our discussions on the very important topic, as well as it is very amazing. At the same time, it will be very interesting if you will go through the classes, and that topic is nothing but locus. So basically locus is going to be used in all of the terms of coordinate geometry. For example, whether we will study straight lines, circle, or any part of conic sections, that is parabola, ellipse, or hyperbola. So in all the topics related to coordinate geometry, we will be seeing locus using in the questions or in other definitions also. So what does locus means is, let's see one by one. We will discuss all the important points related to a locus. So today's topic is going to be locus. So if I have to write the definition for locus, then it will be something like locus is a path. Locus is a path traced by. Locus is a path traced by a moving point. Locus is a path traced by a moving point which follows a certain geometrical conditions. Which follows a certain geometrical conditions. So basically locus definition is written here. Locus is a path traced by a moving point which follows a certain geometrical conditions. What does this mean is, it is saying that it is a path traced by a moving point which follows a certain geometrical condition. There will be certain geometrical conditions implement based on that we will be defining the equations for that the path traced by that we will be finding the equation of that path. So basically what does this mean is, it is trying to say that locus, so if we will have to understand with the examples, then we will see that suppose we have certain geometrical conditions. The conditions are, let's say the x is equals to a and y is equals to a. What does this mean is, at the every point here a is some variable. For example, a can be 1, 2, 3 or any real number, any rational, irrational, or anything. So if x is going to be equals to a and y is also going to be equals to a, then what the equation we are going to find, or what the path we are going to trace by this condition. Let's see, if we will solve these equations, let's say this is equation number 1 and this is equation number 2. So from equation 1 and 2 we will be seeing will be writing it as, since all right hand sides are equal, it means left hand sides are going to be equal among each other. So basically x is going to be equals to y, and we already studied in class 10th also to plot the graph of y equals to x, and we are very much sure that this graph is follows the, it is a straight line basically. So we will learn very much in very deeper. We will learn in depth about the plotting the graph of any straight lines, or everything regarding a straight lines, or whether it is writing any equations related to straight line. We will be learning very clearly in later classes. So let's see. So what we got is, here x is equals to a and y is equals to a. It is the condition given to us. After solving this, we got x is equals to y. This is the path traced by this given geometrical conditions. So basically this is a locus. This is a locus for this condition. So if we have some other conditions, for example, if we are taking so suppose if we are having x is equals to a square and y is equals to a. So this is the condition given to us, and based on this condition we need to plot the graph, or we need to find the equations of the locus. How we will do is, we will just solve it. For example, here y equals to a, it means a is equals to y. So we will replace this here. We will be getting a is equals to a square. We will substitute y in place of a. So we will be getting here y square. X is equals to y square. And if we are aware about quadratic equations, then we have already gone through these concepts, that when this type of equation is there, it means it is a parabola. So this is a parabola. It is not mandatory that we should know here, because in depth also we will learn this. So basically this is what we want to say here is, after solving these two equations, we got the equation number here, x is equals to y square, which means it is following certain geometrical conditions. After solving it, we got some equations. That equation is nothing but this is the locus for this geometrical condition. Similarly, say if we have another points, for example, let's say if we have a x is equals to a, and suppose y is equals to under root 9 minus a square, sorry, 9 minus a square. Okay, so basically x is equals to a and y is equal to under root over 9 minus a square, and these are the geometrical conditions which is given to us, which means that x is going to be always equals to a is variable, and if something a is there, based on that y equals to root over 9 minus a square. So what will be the path traced by these both conditions, or what will be the equations after solving these two conditions? So let's say here we will just solve, we will replace x in place of a, because x is equals to a. So from here we can write here as 9 equals to 9 minus a square, that is 9 minus x square. After solving it, what we can write, after squaring, y square equals to 9 minus x square. Again, if we will solve it, then we will be getting it as x square plus y square is equals to 9. So x square plus y square is equals to 9. It is nothing but a circle with radius 3. Let me say that here, suppose we are getting these equations, and this is a circle of radius 3. So basically, what the important point is, the condition given to us. This condition implies that y is equals to root over 9 minus a square, which means y is always going to be positive, because right hand side is given that root, and root in the value of root is never going to be negative. So basically y is always going to be the positive. So if y is always positive, then from this graph we can clearly say that y is never going to be the negative. It means this is x-axis and this is y-axis. Positive y means that it is going to take the value from upper first and second quadrant only. It means this is not going to be the part of this condition, because y is going to be positive always. This is the condition. If we will be taking the third and fourth quadrant also, because then it means that y is going to be negative, and we have been certainly restricted to take the negative value for y. So basically this is the graph for this condition, x equals to and y equals to root over 9 minus a square. Similarly, let's say if we have some other conditions also, and based on that we need to find the locus, then what will be that? Basically we are trying to understand what is locus. Locus is we can say it is just the curve, or any geometrical figure, or any standard equations which we have read till now. So basically, let's say if we have another points, that is x is equals to, let's say, 4 cos theta, and y is equals to 4 sin theta. So this is the condition given to us, that x is going to be this value and y is going to be this value. So in this case, theta is variable. So if theta will change, then the value for x and the value for y is also going to change. So if these values are changing, then what the curve will be plotted after putting all the values for theta. For example, here, so if we will solve these two equations, from here what we can write, x by 4 is equals to cos theta, and from here we can write y by 4 is equals to sin theta. This is equation, let's say equation number 1, and this is equation number 2. And we all know that sin square theta plus cos square theta is going to be equal to 1, and this is the identity. So from equation 1, from equation 2, we can get sin square theta plus cos square theta is equals to, we will square both the sides. So from here we will be getting y by 4 whole square, x square by 4, x by 4 whole square plus y by 4 whole square. So after solving, we can write it as x square plus y square upon 4 square, and that is equals to x square plus y square is equals to 16. So basically again we are getting circle. This is the equation of circle. If you are not aware about this equation, which geometrical condition this follows this equation, so it is nothing to bother about, because we will learn again in depth. So basically we are as of now we are learning locus. So locus is a moving point which follows certain geometrical conditions. So basically here what it is, for example, theta changes, the value for x and y also get changed, and if we will plot all the points after getting x and y, we will be seeing that it will follow this equation, and this equation is going to be it is going to be a circle. I'm just drawing circle because to let you understand what the locus is. Basically, if we will change the value for theta here, the x coordinate and y coordinate will also get changed. Certainly, after plotting all the points for x and y coordinates, possible point for x and y, so we will see that it is creating a circle of radius 4 units. Basically, the diagram which we have got after solving this, it is the locus for these geometrical conditions. So locus is a graph of any curve or any equations which we get after solving the given geometrical conditions. So as of now, we have gone through the basic definitions for locus, and we have just seen what the locus means, and we have gone through some important related topics for locus. So let's see if you need to solve further questions for locus, how we will approach to solve the locus, and how we will come forward to our question to our answers. Let's discuss that. So our next topic is going to be steps to find the locus. Steps to find locus. So the step number 1 is going to be, we will interpret the questions, we will try to understand what the problem wants to say to us. So what we will do is, we will mark the given conditions, and plot the rough sketch, So we will here, what we will do, we will try to understand what the question wants to say, and we will plot a rough sketch for that question. Suppose it is given that there is a point is moving in such a way that it is following certain conditions. So that conditions we will plot into some rough sketch to solve our problems. So after that, we will follow the step number 2. We will apply the formula or whatever the conditions given. Apply the conditions given. Apply the given conditions. And finally, after applying all the conditions, for example, it is saying it is a locus. Find the locus of a given condition. The conditions is it is at a fixed distance from certain point. So we will apply those conditions here. So now step number 3. After applying the conditions and solving, apply the given conditions and solve it. After solving, we will replace h comma k. We will take here also only, mark the given conditions and plot the rough sketch. Consider point P as h comma k to be the locus. In step 1 only, we will mark the given condition as the moving point will be our P, and we will consider the moving point P to be the locus. Consider moving point P as h comma k to be the locus. So in step 1, what we have done, so here replace h comma k with x comma y to get the final equation, to get equation of locus. So all the steps have been written here. So steps to find locus. So suppose we have been given any questions related to a locus, and we have been asked to find the equation for that locus. So what are the steps to be followed? Step number 1 is, mark the given conditions and plot the rough sketch. Consider moving point P as h comma k to be the locus. So what we will do is, we will plot a rough sketch regarding the conditions given to us, and we will mark the point P as moving point, which is going to be our final equation for the locus. So next, we will apply the given conditions and solve it. Whatever the conditions given to us, we will apply it, and we will solve it to get the final equation in terms of h comma k. And finally, in step number 3, we will replace h comma k with x comma y to get our equation for the locus. So let's understand these steps in a very clearly way by solving some problems. So let's say we have been asked to find the equation of a locus. So in what will be our approach to solve it, and how we will achieve it. So let's say we have been given questions. So here is our first question based on the locus. So question is find the locus of a point whose distance from origin is always equal to 4. So as before we have seen that how to find the locus of any given conditions. So we have been provided with three conditions. We have discussed three conditions. So sorry, three steps. So step number one was to identify the problem and to mark the rough sketch for the problems. So in this case, so suppose our first step is going to be to mark the rough sketch. So what the problem is saying is find the locus of a point whose distance from origin is always equal to 4. So let's say this is origin O. So if it is origin, its coordinates are going to be 0, 0, and its distance from origin is always equal to 4. So let's say this is point P. Point P is a moving point, and we have been discussed that we have to take this moving point as coordinates of this moving point should be h comma k. So as discussed, we have taken the moving point P as h comma k, and now it has been given that the distance is always equals to 4. Distance is given between OP is going to be equals to 4 units. So basically the distance of O from P is going to be always 4. So distance of OP is going to be equals to 4. And now this was the step number 4. Sorry, step number 1, which it means that we have identified the problem, what the problem wants to say, and after based on that we have plotted the rough sketch, which means that there is point O, that is origin, and there is point P, that is moving point, that is h comma k, and it has been given that distance of OP is always going to be equals to 4. So we have marked this OP as 4 units. So now in step number 2, we have discussed we will apply the logic or the conditions whatever we have been asked, whatever we have been given, and we will solve it. So let's say here we have been given that OP is equals to 4. Distance of O from P is always going to be 4. So OP is going to be written as, using distance formula, we will write it as h minus 0 whole square plus k minus 0 whole square, that is equals to 4. And here we will square, and squaring both sides we will be getting we will be getting it as h square plus k square is equals to 16. So this is the step number 2, and step number 3 we have discussed. Here in step number 2 we have applied the logic and we have solved it, and finally we got the equation h square plus k square is equals to 16. In step number 3 we have discussed that we will replace h comma k with x comma y. So in what we will do here is we will just replace h with x and k with y. So here it will be x square plus y square, that is equals to 16. This is the final equation. This is the final locus which we have been which we were required to find. This is the equation this is the locus which we were about to solve it. This is the final answer. So let me revise again. So in step number 1, what we have done, we have identified the problem, we have gone through the statement of problems, and we have plotted a rough sketch. Based on that, we in step number 2 we have applied the logic, we have applied the conditions given to us, that is OP is equals to 4. So we have applied distance formula here and we got the equation, and after solving it we got h square plus k square is equals to 16. And in step number 3, as discussed, we have seen that we need to replace h with x and k with y in order to get the final equation for the required locus. So here we got final equation as x square plus y square is equals to 16. So this is the answer for first question. Very basic question, and it is required to understand the problem with this question only. Okay, let's start with second question. So here we have question number 2 for locus. So question is find the equation of locus of a point which moves so that its distance from the axis of y is always 1/3 of its distance from the origin. So basically we have been asked to find the locus of a point. Basically in this question there are two distances, one is from y-axis and the one is from origin, and we need to equate those two distances. After solving it we will be getting the required locus. So let's see here what we have to do. So in step 1, I am writing here stepwise because just to let you understand how to approach the problem of a locus. So step 1 is here, find the equation of locus of a point which moves so that its distance from the axis of y. So basically two distances are involved. Let's say this is the moving point P h comma k. In order to plot the graph, in order to plot the rough sketch, we have been taken point P as h comma k. This is the moving point. So I am writing here, this is the moving point. This is the moving point basically. So h comma k is the coordinate for this point, and what the step 1 is, this is to plot the graph. So here distance from axis of y, this is the axis of y, and this distance is going to be h unit, because this is the x coordinate distance. This is going to be h unit, and another distance is from origin. This is the origin with coordinates 0, 0, and this distance is going to be, we can easily find this distance of OP, because we have to apply the distance formula. That's it. So here let's see, this is O and this is A. So basically here it is given that distance from axis of y, this h, that is AP, is going to be 1/3 of its distance from the origin, that is OP. Basically this is given to us. From step 1 we have found that what the required conditions are given, and we have plotted the rough sketch for that condition. So in step number 2 we will apply the geometrical conditions, and we will solve it. So here we will solve it, this condition itself. So it is given that AP is equals to 1/3 of OP, and we will find the distance of AP, that is equals to h unit, because we have been given this point. So this point coordinates are h comma k. It means that its distance from y axis is going to be x coordinate of this point. So this is h. So here h is equals to 1/3 of OP. If we need to find the distance OP, we have 2 points. We will apply the distance formula. So it is root over x, h minus 0 whole square, that is h square, plus k minus 0 whole square, that is k square. And now we need to solve this equation itself. So how we will solve it? We can write it as 3h is equals to root over h square plus k square. We will square both sides. After squaring, we will be getting it as 9h square is equals to x square plus y square, and that's it. So after solving it, sorry, here it is h square plus k square. So it is h square plus k square basically. Now we will solve it. So we can write it as 8h square is equals to k square. This is the final output we have got. So now in step number 3, what we will do, we will replace this h with x and k with y. So final equation will be, so if we need to write the final equation, so in step number 3, what we will do, we will replace point h comma k with point x comma k. So here we will be writing it as 8x square is equals to y square. This is the final equation for our locus. This is the answer. So it was the question was, there is point p h comma k that we have assumed this is the moving point, and this point is remain here in such a way that its distance from y axis is going to be equals to 1/3 of its distance from OP, from origin. So we have written this condition only. AP is going to be equals to 1/3 of its distance from origin, and after applying AP is going to be h, and this is equals to 1/3 of distance from origin. It is h square plus root over h square plus k square, and after solving we got 3h equals to this, and after squaring we got this, and again simplification we get 8h square is equals to k square. So and replaced with h with x and k with y, finally we got this equation to be the locus, required locus. So this was our second question. Let's move to the third question. So our third question looks like this. Find the locus of a point whose distance from the point 4, 1 is equal to its distance from the axis of x. Same question, almost same. What we are going to do is, we will identify the problem, what the problem wants to say. Basically, let's say this is our x-axis and this is y-axis, and let's say here we have got a point 4, 1. So 4 unit 1, this is, let's say, point A. This is 4, 1, and now there is moving point P. We need to find the locus of a point whose distance from point is equal to its distance from the axis of x. Let's say this is point P, which is our moving point h comma k. So we have assumed our point P to be this one, and now this is given that distance from point 4, 1. This distance, that is AP, is going to be equals to distance from point 4, 1. So we have taken the distance of this moving point h comma k from point A, that is 4, 1. This distance is going to be equal to its distance from the axis of x. So distance of point P from the x-axis, basically this distance. So this, let's say this is B. So we know if there is a point P with coordinates h comma k, and we need to find the distance of this point from x-axis, this is nothing but the y coordinates of this point. So basically this is k unit, this distance. So it is given that AP is equals to BP. So basically it was given, we have been given one point A, that is 4 comma 1 with its coordinates, and we have the moving point h comma k, which we have assumed this is the moving point, and now we know that its distance from the point 4 comma 1 is equal to, that is AP is equals to its distance from its distance from the x-axis, and we know distance of any point from x-axis is the y coordinates of that point. So it is k. So basically here our step 1 has been done. Now we are going to move into step 2, that is we will apply the conditions and we will solve it. So here AP is going to be written as root over h minus 4 whole square plus k minus 1 whole square, and this is going to be equals to distance of P from B, it is nothing but k. So here it is k. After squaring both sides, what we will be getting here as, it will be h square plus 16 minus 8h plus k square plus 1 minus 2k is equals to k square. So k square will cancel out among each other. So after solving here, what we will be getting as h square plus h square minus 8h minus 2k plus 17 is equals to 0. This is our final equation in terms of h and k. After solving, we got this equation. This is going to be our final answer after replacing h with x and k with y. So step number 3 is going to be, we will replace h with x and k with y. So here we will be getting as x square minus 8x minus 2y plus 17 is equals to 0. This is the answer. So what the question was saying, it has been asked to find the locus of a point whose distance from any point 4 comma 1, that is 4 comma 1 is here, and let's say our moving point is h comma k, moving point is P with coordinates h comma k. So its distance is going to be root over h minus 4 whole square plus k minus 1 whole square, and this distance is going to be equals to distance of this point from the x-axis, and this is k. So this is equal to k. After squaring both sides, after solving, we got these equations. So h square plus 16 minus 8h plus k square plus 1 minus 2k equal to k square. K square got cancelled. So here h square minus 8h minus 2k, 16 plus 1 17 equals to 0. After further we have replaced h with x and k with y in order to get the final equation for our required locus. So this was the solution for our question. So locus, now we are able to identify what the locus wants to say, what the meaning of locus is. So basically we have been we need to assume some one moving point, that is P with coordinates h comma k, and we will apply the conditions, the given conditions, that in this case it was given that AP equals to BP, and we need to simply solve the equation based on the distance formula. And after solving, we got this equation. After replacing h with x and k with y, we will be writing the final equation for required locus. So this is the condition. These are the steps which we need to follow in terms of any questions related to locus, whether it is related to straight lines. Right now we are studying straight lines, so we are taking the problems till we have studied all the concepts. In later classes, after studying all the coordinate geometry portions, for example, circle, conic sections, parabola, and hyperbola, we will be getting all the questions related to locus. So there we will be using more logic, which we have already discussed till that point. So it will be the concepts will remain same. The logic will get changed, but the concept is going to be the remain same. The concept which we are discussing right now only. So as of now, just try to grasp all the concepts related to locus. So let's move to the fourth question. So here we have question number 4 for our topic locus. The question says a rod of length L slides with its ends on two perpendicular lines. Find the locus of its midpoint. So what the condition has been given to us, so we will try to identify the condition, and we will plot the rough sketch for the same to move further to find the solution for our questions. So here, let's say two perpendicular lines are given. This is perpendicular. So we have been given two perpendicular lines. So we will assume two perpendicular lines to be x-axis and y-axis respectively. So let's say this is x-axis, this is y-axis, and obviously these two axes are already perpendicular to each other. So our question is going to be suitable for this condition also. So now it is saying a rod of length L slides with its ends on two perpendicular lines. So basically, let's say it is sliding, let's say in this way. These are two ends. Let's say this is A and this is B. So our rod AB of length L is given. So length of AB is going to be L, which is given in the problem itself. The length of AB is going to be L, and what it is saying is find the locus of its midpoint. So let's say here we are assuming midpoint is going to be our locus. In the problem itself, it has mentioned that our locus is going to be midpoint of this rod AB. So if it is point P, which we are assuming to be the locus, so obviously we are going to take the moving points, the coordinates of this moving point to be h comma k. So as of now, we have taken we have the formula. Sorry, we have the length of rod AB, that is equals to L. So what we are supposed to write our final equation is what we are knowing. We have length of L, so L is given to us, and after solving the equations, we are assuming that there will be x coordinates or y coordinates, or equations in x and y and L is required to be final answer, because as of now the question already given the length is L, and after solving we need to write the equation in terms of x, y and L only. Suppose we are taking any variables in any questions of locus, so we are supposed to remove those variables before solving the final equation. So here, so let's assume this is the length of B from origin. This is origin. So let's say this is origin, and length of, let's say this is going to be the B. I'm taking this because we are going to take this points as A comma 0 and this one as B comma 0. 0 comma B. Just to avoid any confusion, I'm taking the points also in the same way. Here point is this distance is going to be A unit. Let's say here this distance is going to be, let's say, B units. So as of now, I have introduced two new variables, that is A and B. So it is my duty, before reaching the final solution, we are assumed to remove these variables A and B from the final equations. So here, what the information we are having? We are having that OA is going to be A, OA is going to be equals to A, and OB is going to be equals to B. This we have already assumed to be this distance. So as of now, we know that AB is of length L, so we can apply Pythagoras theorem here. So in triangle ABO, A square plus B square is going to be L square. So now we have got this relation between AB and L. So further, we have been asked to write the locus of its midpoint. For this point, we have to think how to write the equation here. So what we can do is, since H is the midpoint of length AB, so we have coordinates of A and we have the coordinates of B, which we have assumed. So we can write it as H is going to be equals to A plus 0 upon 2, that is equals to A by 2. So basically A is going to be 2H. Similarly, K is going to be equals to, since K is the midpoint, y coordinates of P, and it is midpoint of the of this rod AB. So K is going to be equals to 0 plus B divided by 2, and that is equals to B by 2. So here we can write B is going to be equals to 2K. So finally we got A in terms of H and B in terms of K. Since we are assumed to remove the variable A and B, because this is not given in our problem, we have introduced this variable into our problems to solve it. So now we will remove this variable A and B. So here we can substitute A to be 2H and B with 2K in this equation itself. So this is equation number 1, this is equation number 2, and this is equation number 3. So we are substituting the value from equation number 2 and 3 in equation number 1. So finally we will be getting here 2H whole square plus 2K whole square, and that is equals to L square. So after simplification, we can write it as 4H square plus 4K square, that is equals to L square. So till step 2 we are done here. The step 2 was about to solve the given conditions, and we have solved it. Now we need to replace H with X and K with Y. This is the simple steps. 4X square plus 4Y square is equals to L square. This is our final equation of the required locus. This is the answer. So this was a good question, one of the good question. So let me summarize this solution. So we have been given the length of AB as L. It is sliding between two perpendicular lines. So we have taken x-axis and y-axis to be the two perpendicular lines, and the rod AB is sliding between these two perpendicular. Its ends are on the two perpendicular lines itself. Let's say on x-axis this end is A with coordinates A comma 0. So these coordinates we have taken by ourselves. For point B, we have taken the coordinates to be 0, B. So whatever the unknown variable which we are introducing in our problem, it is our responsibility to remove those variables to get the final equation for the locus. So here we have taken A as A, 0. So we know length of AB is given to be L. So we will use distance formula. We can also use distance formula here also, but here I have applied Pythagoras theorem. So here from here, A square plus B square is going to be equal to L square. So we got the equation number 1. And since we know this point P is going to be the midpoint for rod AB, so since it is in midpoint, so H is going to be equals to A plus 0 upon 2, K is equals to 0 plus B upon 2. Similarly, we got here A as 2H and B equals to 2K. So since we got A in terms of H and B in terms of K, so what we have done, we have replaced this value in equation number 1 to remove variable A and B. So as expected, we have removed the variable A and B by substituting its value into the equation number 1. So from here we got 2H, we have put a value of A to be 2H and value of B to be 2K. After solving it, we got 4H square plus 4K square equals to L square. Totally step number 2 we are done here, and after in step number 3 we are expected to take replace H with X and K with Y, and we have done the same thing here. We got 4X square plus 4Y square equals to L square. This is the final equation which we were required to find. This is the question number 4 of locus. So our question number 5 is, let O and A, coordinates of O is 0, 0, that is origin, and coordinates of point A is 0, 1, be two fixed points. Then the locus of point P such that the perimeter of a triangle AOP is 4. So this question has been already asked in JEE Mains 2019. So let's say what is going to be the solution and what are the approach, how we will solve it. So it is given that, so it has been given that, let's say this is origin with coordinates 0, 0, origin with coordinates 0, 0, and point A is given to be 0, 1. So let's say here it is 0, 1. So it is 0, 1. So point A is going to be 0, 1. It is going to be here. Okay, so this is point A, and these are two fixed points. So now then the locus of point P such that the perimeter of triangle AOP is 4. So we need to take our variable point P. Let's say we are taking P to be here, and let's say this is H, K, and it has been given that area of triangle AOP. Sorry, area is not given. Perimeter is given. So here perimeter is given that it is equals to 4 unit. So what given to us? So we can find this distance. It is obviously 1 unit. So now we have been given distance of OA plus distance of AP plus distance of PO. This is going to be 4 units. Since this is the perimeter, perimeter is just sum of all the sides of any given geometrical figure. In this case, this is triangle. So sum of all the sides of a triangle is going to be the perimeter for this triangle, and this is given to us with 4 units. So here side length OA is going to be 1 plus side length AP plus side length PO is going to be equals to 4 units. So after solving it, we got AP plus PO is equals to 3 units. So now we need to find the distance. We need to use distance formula and apply here to find the distance of AP as well as distance for PO, and after that we just need to solve it in step number 2 as we have discussed. So this simple as problem of locus is very simple if we are clear with the definition, what the condition has been given to us and how we need to apply it and how we need to solve it. So this is the condition. First step has been drawn, that we have drawn the rough sketch. In step number 2, we have been asked to write the conditions and to apply the formula, and whatever the given conditions are there, we just need to solve it. So here distance of AP is going to be equals to, AP is going to be, this is the AP, so H minus 0 whole square, so root over H minus 0 whole square plus K minus 1 whole square plus PO is going to be root over H square plus K square. This is equals to 3. So we will take one of this square root to the right hand side and we will just solve it. So from here we got H square plus K square plus 1 minus 2K is equals to, let's say this is 3 minus root over H square plus K square, and we have applied squaring both sides. This is the square. So here already we have done the square. Here right hand side we need to do it. So further we need to solve it. So here, after solving, we will be writing is as h square plus k square minus 2k plus 1 is equals to a square, that is going to be 9, plus b square, which is going to be h square plus k square, minus 2ab, which is going to be minus 2 times multiplied by 3 root over, the b is root over h square plus k square, h square plus k square. After more simplification, what we can write here, h square plus k square got cancelled. So from here we got minus 2k plus 1 is equals to, also 1 can be sent to right side, so it will be equals to 8 minus 6 root over h square plus k square. So we need to solve it further. What we can do here is, we can write minus k is equals to 4 times minus 3 root over h square plus k square. So now we can do here 3 times root over h square plus k square is equals to 4 plus k. Again we will square both the sides. So from here we can get 9 times h square plus h square plus k square, h square plus k square, which is equals to 4 plus k whole square. So this is going to be equals to 16 plus k square plus 8k. So we need to solve it more further. So from here we can write it as 9h square plus 9k square minus k square, that is going to be 8k square. From here it is 16 plus 8k. So we can take all the to the right left hand side all values. So 9h square plus 8k square minus 8k minus 16 equals to 0. So this is the final final result which we have solved after applying the just geometrical conditions what we have been given. So replacing h with x, so we got 8x square plus 9y square minus 8y minus 16 equals to 0 is going to be our final result. This is going to be a final equation for the required locus. This is the answer. So the problem was very simple. Let me illustrate once more. So it has been given that there are two fixed points and those points are origin and the point A, that is 0, 1 unit upper to the origin. So this distance is going to be 1 unit, and it has been asked to find the equation of locus. Let's say there is point P which is a moving point, and it should move in such a way that the perimeter of this triangle formed by AOP is always to be remain constant, and that constant is going to be 4. So what we have taken, moving point P we have taken with coordinates h, k, and we have just applied the conditions that all the distances of these three side lengths of triangle is going to be equals to 4 units, and we know this is 1 unit, so it means that distance of AP plus PO is going to be equals to 3 units. So we have done write the distance, we have used distance formula to get the distance AP as well as for the distance OP, and we have just solved the equations by squaring. After one squaring we got some equations, and we need to take another squaring here. So we have done another squaring here. After solving this we got this equation, and finally we have replaced h and with x and k with y to get the final required result. So as of now we have discussed what the locus is, how to apply, how to implement steps of locus to find the equation of required locus in our problems. So we have taken some of the few problems, and we have taken one of the previous year questions, that is JEE Mains asked problem 2019. So also we have solved, this was nothing tougher, it was very easy problem in JEE Mains. It has been asked in JEE Mains 2019. So the approach is remains same, it is going to be remain same as I have already said. So the logic is going to be same. The more and more logic we will study further in our coming classes in the more concepts of coordinate geometry. So we'll apply those concepts also in the problems of locus. Our questions will get changed based on the topics we have studied. So as of now we are stopping here. It is expected that you will try to get all the topics till now which have been covered to you, and try to solve all the questions taken into the class of this our lectures. So meeting in another lecture with some another topic. So we are expected to take the another topic, that is going to be slope and writing the equations of straight lines. So what various forms of straight lines will be there. So it is expected that if you will study in by your own before joining that class, it will be very much beneficial to you to get all the topic concepts very much clearly. So okay, meeting in next classes. Till then, take care. Bye bye. Okay, bye.